The seasons explained. I can model and illustrate how the tilted Earth rotates on its axis, causing day and night, and revolves around the sun, causing changes in seasons. The Earth revolves around the sun in a shape that's not quite a circle. Because the orbit is not perfectly round, the Earth is closer to the sun at certain times during its orbit. But this is not the reason we have seasons. The Earth's axis is tilted at 23.5 degrees. The amount of tilt on the axis towards or away from the sun changes with the various positions of Earth in its orbit or revolution. The tilt and the revolution are the reasons for seasons. In summer, San Antonio experiences more hours of daylight than darkness, and the longest day on June 21st and 22nd each year. On this day, the sun's rays strike more directly on the northern hemisphere. In winter, the Earth's axis is tilted away from the sun. San Antonio experiences more hours of darkness than daylight, and the shortest day on December 1st and 22nd each year. On March 21st, spring, and September 21st, fall, the Earth's axis is neither tilted toward nor away from the sun, and the sun's rays strike directly upon the Earth at the equator. As a result, the changes in the amount of solar energy hitting the Earth at various times throughout the year, we experience different seasons. For the Northern Hemisphere, we're going to drag and drop the season's name and the statement to each position. So we're looking at the Northern Hemisphere only, and we're going to decide what season it is. So looking here, the Northern Hemisphere, the half of the Earth that's above the equator, is pointing away from the sun. So we're getting indirect sunlight, so it's winter, where our days would be shorter. So I'm going to minimize, and we're going to drag and drop that title. So winter is the season in the Northern Hemisphere, and the description would be sun shines directly on the Northern Hemisphere? No, sun shines indirectly on the Northern Hemisphere. That's what's going to give us winter. Okay, the rays are indirect, so we're winter. And let's do a revolution counterclockwise. So at this position, we're going to skip because these are going to be our equinoxes where we can't tell which hemisphere is tilted towards or away from the sun. And let's go to this model on the left. Here I'm looking at the Northern Hemisphere, and I can see the Northern Hemisphere is tilted towards the sun. So the Northern Hemisphere is experiencing summer. So let's drag and drop our season. And then our description is the sun shines directly on that Northern Hemisphere. That means I'm going to have longer hours of daylight and warmer temperatures. Now we can go to these equinoxes by saying our seasons in a counterclockwise rotation. So if I have winter here and summer, I know it goes winter, spring, summer, fall. So I'm going to drag my spring over in my Northern Hemisphere, and that's where the sun shines equally on the Northern and Southern Hemisphere. So I have winter, spring, summer, fall. And again, that's where the sun is shining equally on the Northern and Southern Hemisphere. We're in an equinox. So let's drag and drop the statements and illustrations where they belong in the chart below. So let's decide what statement is talking about summer in the Northern Hemisphere and fall in the Northern Hemisphere. So long days, short nights. When I have long days, it means I have more sunlight, so it's summer. Neither the northern or the southern hemisphere is tilted towards the sun, fall. Northern hemisphere is tilted towards the sun, that's summer, where we get the direct rays. The sun shines directly on the northern hemisphere, that's summer. The length of the day and night are equal, fall. Sun shines equally on northern and southern hemisphere, fall. Next slide. Let's drag and drop the statements for winter in the northern hemisphere or spring in the northern hemisphere. So short days, long nights, that's winter. So we have those long nights, less sunlight. Neither the northern hemisphere or the southern hemisphere is tilted towards or away from the sun. The northern hemisphere is tilted away from the sun, that's winter. Sun shines indirectly on the northern hemisphere, that's going to be winter. Length of day and night are equal, spring. Sun shines equally on the northern and southern hemisphere. Directions. Let's drag and drop the boxes to label the diagrams as follows. Label the northern and southern hemispheres. So here we go. Northern hemisphere is the half of the earth above the equator. So we can do that in each of these images. Then your southern hemisphere is going to be the half of the earth below the equator. Okay. Label each season in the northern hemisphere: winter, spring, summer, and fall. So I'm going to start here and we're going to go counterclockwise, but I need to move these labels so I can see my axis and my equator, the hemispheres, being tilted towards the sun. Let me just move these out of the way. Okay, and so what I'm going to do, I'm going to start with my models on my right and the model on the left, and I'm going to go counterclockwise. So here you can see the northern hemisphere is tilted towards the sun. I can see the imaginary axis and the upper part of the northern hemisphere tilted towards the sun. So here I have summer. So remember, in summer we have direct rays hitting that northern hemisphere, so I have longer hours of daylight and warmer temperatures. As I do my revolution around the sun, I'm going to skip my equinoxes and go here to this model. Let me move those labels. And here you can see your axis in your northern hemisphere is tilted away from the sun, so this is winter in the northern hemisphere. In winter I have indirect rays, so I have longer hours of darkness and cooler temperatures. Now we can do our equinoxes. Here it's telling us it's September, so we can go backwards this way: winter, spring, summer, fall. So I'll go ahead and grab spring and fall. Okay, so I knew my seasons in order: winter, spring, summer, fall. For our connection and exit questions, how does the Earth's revolution around the sun in its relationship to axis cause seasons? So the reason for seasons is Earth's 23.5 degree tilt as it does a revolution around the sun. So the hemisphere that's tilted away from the sun is winter, and the hemisphere that's tilted towards the sun, it's summer. What happens in the southern hemisphere when the northern hemisphere is experiencing summer? So if we are summer in the northern hemisphere, we're the opposite in the southern hemisphere. So northern hemisphere summer, southern hemisphere winter. When it's winter in the northern hemisphere, what would the amount of daylight be like in the North Pole? So in the northern hemisphere, if it's winter, our northern hemisphere is tilted away from the sun. We're getting indirect sunlight, so the daylight would be short and your nighttime would be longer. All right, I hope that was helpful.